Good morning, everyone, and thank you for joining us for the HughesON webinar, Enabling Broadband for the Enterprise Applications. I would like to introduce Tim Tang, our speaker for this morning. This webinar is being recorded, and it will be available for on-demand view starting tomorrow. We hope you enjoy.
Hello, everyone. My name is Tim Tang. I'm a product marketing director at Hughes. I have the privilege of looking at vertical industries, looking at retail, restaurants, banking, and finance. And my role at Hughes is to take a macro view of all the changes that are taking place, the major trends, and then trying to find solutions and trying to understand what the customer's needs are and trying to develop solutions and strategies for addressing and meeting those needs. Today we're going to be talking about broadband, and primarily because there's quite a bit of activity that's been taking place across all the major industries that I've been taking a look at. It's no surprise in our society that there's a massive wave of digitization that's taking place. You can see it in retail from just all the technology that has recently entered in the stores. A lot of it's being generated by fairly significant competitive threats from online retailers, so much so that many of the brick and mortar locations are trying very hard to leverage all kinds of digital techniques and solutions to dramatically enhance the customer's experience in the brick and mortar stores. Similarly to retail, we have a similar phenomenon that's also taking place in the restaurant industry too as well. I think retail began its digital transformation probably 4 or 5 years ago, where Amazon and other online retailers became very prominent and effective in their ability to provide an alternative channel to the consumer. More recently, in the past year, though, in the restaurant industry, a very similar type of approach, where a whole wave of digital technologies now has really improved and increased the competition for customers. So much so that we're competing for customers now while they're still in their living rooms at home and trying to get them to make commitments, make reservations, even order their food before they've even left the home. A lot of the needs in the restaurant industry are very similar to what we saw in retail. The need for guest Wi-Fi type solutions, the need for more capacity in the restaurant, as we saw with the stores. A lot of this is driven by the use of cloud-based applications, loyalty programs, and the opportunity to leverage multimedia in the store and in the restaurant too as well. With these new capabilities, we see a lot of new requirements, not only for bandwidth, but also for security, and also for being able to prioritize and be able to manage all the different types of traffic, particularly as it relates to things that impact the customer, such as the point of sale and the weight that might be associated with that. Also equally interesting is banking and finance have undergone a similar transformation too as well. Entire business models have been completely turned over. We've seen a world that was really based primarily on the transactional natures of depositing your checks and into your saving accounts, now transformed into more of a value add. As consumers move to mobile banking, their need for the branches have evolved dramatically. And in a lot of our discussions with many of our banking customers, there's a desire now to actually find ways to add value to that customer's experience, to motivate them to actually want to come and visit the branch more often. So with all of this digitization, the question becomes, how much bandwidth do you need? How do you support all of these new digital experiences, whether it be in the store, whether it be in the restaurant, or also even in the bank? Across the board in the distributed enterprise, we've moved from a world where a 1.5 meg type circuit has, over the past couple of years, has increased to 3 meg, 6 meg. Now we commonly see 10 meg as a baseline for network capacity into the branch locations. What's driving all this? It's primarily a lot of the move to the back office. We've gone from a world where it was primarily transactions. For many of these industries, it was small transactions throughout the day. For retail, restaurant, it'd be primarily your credit card transactions. And then overnight, it'd be some sort of daily polling applications, pulling down one large file. And for the vast majority of the customers that we dealt with, it was essentially this template, a very small transactional need during the daytime, and then an overnight polling download requirement at night, and that was essentially it. We've moved from this closed private world now into a more open world that is now more and more dependent on third-party applications, which have brought along with it the need for open access to the internet. We no longer have the luxury of a completely closed network, but we've got to let these third-party applications in, and that introduces, as one could expect, some fairly significant security requirements too as well. So here's the problem. Whether it be in retail, whether it be in restaurant or banking, our fundamental challenge is how to improve that customer's experience in the distributed branch location. Whether it be a clienteling application, an interactive kiosk, perhaps an ordering application, or just anything with some sort of, the interactive kiosk is also a very good example where we're actually trying to pull video or pull content down. The consumer at home, many studies have confirmed that they'll barely tolerate 3 to 6 seconds waiting for a web page to download. Now they're coming into a distributed branch location, a restaurant, a store, a bank, and to wait even longer is even worse. They're sharing a much, much smaller pipe. At home, they have 10, 20 megabits of capacity. In a branch, they may have a few megabits that have been allocated for internet access for guest Wi-Fi, and they may be sharing that with dozens of other consumers at the same time. This is a setup for a very unsatisfactory experience for the consumer. And so it's because of this that we've started to see an interesting transition now, where for most enterprise networks, your core solution has always been a T1 MPLS type circuit. The T1 is reliable, the T1 is trustworthy, the T1 is dependable. We know what we're going to get, and we know how to manage our applications over it. Broadband typically gets a much tougher reputation. Sure, the capacity is dramatically cheaper on a price per megabit type basis, but along with that comes a lot of strings attached. There's sometimes, when it gets congested, not enough capacity. Sometimes there's latency issues, packet loss, and congestion loads. And because of that, for many enterprise applications, there's a real reluctance to leverage or try to attempt to use broadband. And that's really what we want to look at today, because while a T1 MPLS is great for its reliability and its dependability, its consistency, at the end of the day, it's 1.5 megabits. And sure, you could buy 2 or 3, but that becomes very cost prohibitive, particularly in today's very competitive market situation. And so now the question becomes, if I can't afford more T1s, and yet I have a market, whether it be restaurant, retail, or banking, that is driving me to the cloud and driving me to these consumer-facing experiences, how do I how do I bridge this gap? When you look at a broadband network, there's a lot of, the challenge is not so much the core, but it's generally that last mile. The closer and closer I get to that distributed branch, the more challenging it becomes to get the kind of capacity I need. And even in the larger my footprint of locations, the more difficult it is for me to have a consistent experience across all of my branches, all of my restaurants, all of my stores, all of my banks. So what we want to look at is how do we take broadband and enable it to support enterprise applications in a reliable, consistent type manner. This next chart is exciting in the sense that we actually have the view, the understanding of what broadband is. When we talk about broadband, it's always an up to 3 megabits and down 768 kilobits. But the question is, you never really know how much of that 3 megabits do I actually get. And if I have 500, 1,000 stores, restaurants, and banks throughout the North American footprint, how much of the up to 3 megs, up to 10 megs of capacity am I actually getting across all my different locations? Which locations, broadband is not the same everywhere. So which one of my locations are experiencing more congestion issues versus which ones are fat, dumb, and happy for the most part. And so what we're seeing here is a typical 3 meg 768 type scenario. But what's really interesting and intriguing for this particular location is, even though it's been provisioned at 3 meg, on average they have about 3.5 meg of capacity that they have available to them. So there's all this extra capacity that wasn't provisioned or wasn't actually anticipated, but is available to that site and to that end user with broadband. Now, it's also appropriate to highlight too as well, there are also some scenarios where, again, it is an up to 3 megabit provision, and so there are scenarios and situations here where we're not hitting the 3 meg provision rate. And these are one of the things that we want to be sensitive to as we think about broadband. Sometimes you actually get more than what you pay for, sometimes you get less. And so now the question is I want to think about how to make the most of my utilization of broadband. I'm going to have to anticipate both of those scenarios and be able to accommodate both of those scenarios. So as we think about broadband, here are the problem areas. When it comes to broadband, the bandwidth changes. Your fundamental difference between a broadband circuit and the T1 circuit is, with a T1 I get 1.5 megabits, 24/7, all the time, around the clock. With broadband, I can get the 3 meg, up to 3 meg. Sometimes I get 3.5 meg, but sometimes it changes. And it's in that change. It's these moments that I've highlighted with the red rectangles here. When broadband decreases in capacity, if the network or the circuit were being fully utilized, like perhaps during a sales promotion, during a lunch hour rush, whatever the case may be, whenever the network contracts, packets are lost. And that's those lost packets. That's what contributes to the pops, the hisses that you hear over voice over IP circuits, or the freezes that you might see over a video transmission, or a point of sale transaction. If I lose lots and lots of data, the network is just randomly throwing away my data. It doesn't actually matter. I may prioritize my point of sale, my credit card transactions at the highest level of priority, but if I feed them into a pipe that's being fully utilized, and then the network contracts, the network randomly starts throwing away packets. And that's the reason why my point of sales transactions may take less than 10 seconds in some cases, but then may take as many as 20, 30, or 40 seconds in other cases during a lunch hour rush. And so while broadband provides a meaningful amount of more capacity, one of the issues that we have is these moments of network contraction. It's always great when broadband increases the capacity. Now, there's no packet loss, there's no impact to my customer's experience in those scenarios. If anything, it improves it. But whenever it contracts, whenever it goes from a higher amount of capacity to a lower amount of capacity, if that circuit's fully saturated, I'm losing packets and I'm losing data, which needs to be retransmitted. And if it's something that's sensitive as a point of sale, then my customer is getting a poor experience. And so this is really the challenge that we have. This is the reason why voice over IP over broadband usually works. It's usually, from a best efforts perspective, it's fine. But when the network gets congested, this is the reason why the voice quality degrades in such a dramatic fashion, and why you get the pops and the hisses. So how do we solve this problem? And from again, as we kind of alluded to here, the T1 doesn't have this. The T1 consistently has the T1. So as we think about broadband, we're going to think about how do we adapt to this. As we think about higher level circuits, going from a 3 meg in this case to a 16 meg, the problem becomes even more magnified. Because even though you may, in this scenario, we have a location that's provisioned at 16 megabits, but what's actually being offered is actually in excess of 22 in some cases. And so you have another 6 megabits of available capacity that's available to you to use. And so it's a fairly dramatic opportunity to increase the customer's experience. Instead of having 100 customers or 50 customers during a peak rush traffic area sharing 16 megabits, they could be sharing 22 megabits. Now, again, this is broadband, and broadband does fluctuate, and so there are periods where you're not hitting the whole 16. It is up to. So the next question then becomes, well, what do you do? What's the right answer here? How do I have an enterprise-like experience with broadband? Some of the common approaches that we've seen is, well, take a conservative approach then. If you're going to provision broadband at 16 megabits, set up your traffic and your routing profiles really for only some smaller portion of that. Don't use the full 16. Give yourself some overhead, 14 megabits, and so that you'll improve the amount of opportunity. And the more conservative you are, 12 megabits, 10 megabits, the higher your customer's experience is going to be. The less congestion will impact your network. This is certainly one way and it's a very common approach in terms of being able to leverage, when you think particularly also in terms of the cost factor. If I'm able to get a 16 meg circuit for a fraction of the cost of a T1 circuit, and then I just back off my usage of the network, I can have a similar experience, if not meaningfully better. But there's, as you can see, a lot of loss when you take that kind of approach. The more we back it off, the higher the customer's potential experience, or the employee's experience for that matter, anybody using the infrastructure will improve. But then also the more is wasted, and it's the more capacity that goes unused. A far better approach is to, in real time, monitor the available capacity. Understand, when does my network have 22 megabits of capacity available for me to use? Or when does my network only have 8 megabits of capacity for me to use? And when my network only has 22 megabits of capacity to use, I let 22 megabits of capacity into the network. But when it changes, like you see in that middle peak there, down to 8 megabits, well then in order to preserve my quality of service and my prioritization, I'm going to, in real time, reduce the amount of traffic from the 22 megabits down to 8. And if I only let 8 megabits of traffic into the network when it only has 8 megabits, then the network's no longer throwing away my packets. In those kind of scenarios, even though the network might be highly congested, even though I may be throwing a full 8 megabits of capacity into it, my voice traffic still stays intact. My video streaming, my remote PC access for troubleshooting purposes, all of my cloud-based applications, all of my point-of-sale transactions still make it through the network the first time. I don't have this scenario where the network is just randomly throwing away my packets. And now I can have that consistent enterprise-grade type experience that I'm looking for out of broadband. As long as we can understand when broadband is strong, we can take advantage of those opportunities and those windows when we have more capacity. I only paid for 16 megabits, but if the network's going to allow me to use 22, I want to use the full 22. But when the network becomes congested and I only have maybe half of that capacity, the 8, well then I only want to allow 8 through so I can still have that enterprise experience, that consistent point-of-sale transaction, that high-quality voice over IP call, make it through the network. I think this is the key. This is the key to making broadband work for the enterprise. A real-time understanding of what's going on in the network, and then only allowing that magnitude of traffic to go through the network. And as long as the amount of traffic you're putting into the network matches what the network can sustain, then you don't have this random effect where data is being lost, point-of-sale transactions are taking forever, or your voice quality is unacceptable. So as we think about leveraging broadband for the enterprise, there's a new KPI to be thinking about, and that's congestion. We need to understand how much, what's the impact of congestion on the network, and we want to look at the network, as a whole. So one way of thinking about congestion is how many minutes of an hour are being, do you have more than 80% of your network being used? 80% of the time your network is fully leveraged. And so what you see here is we've got a situation here very similar, another 10 meg circuit in this case, in this example, where we provision a 10/1. And generally speaking, at the 10 meg rate, we're counting the number of minutes per hour that we see congestion. And what you have here is, actually in the dead center of this is actually an outage that takes place, I think, on a Sunday morning, where for whatever reason we went from a 14 meg availability down to just several hundred kilobits in that window. And you see the congestion kind of creeps up because now we're using basically all the available capacity. But the idea here is that if we can understand the level of congestion that's taking place in the network, then we have an understanding of what we need to do in terms of managing our network infrastructure. We can know that over a 500,000 site deployment in a nationwide type scenario, which networks need 6 meg broadband, which networks need 10 or even 20 meg upgrades. We can actually be very selective and very particular now of how to improve performance across the board. And so from as we think about the infrastructure perspective and we think about leveraging broadband for enterprise purposes, we want to have an understanding of what's going on in the network. We want to have an understanding of what's available to us to use, and then of what's available for us to use, how much of it is actually being used, and what is and as levels of congestion increase, whether it be for internet congestion of the network at large, or high levels of usage from our employees or our customers in the store. We want to be able to adapt our usage profiles. In many cases, as we think through other best practices to consider for enterprise use of broadband, some of the other things that come to mind are, in addition to the advanced kind of prioritizations that we're talking about, is leveraging WAN optimization techniques to virtually magnify the amount of available capacity. So if we have 10 meg, or in this case a 5 meg circuit, if we can leverage compression techniques, byte level compressions, to magnify that 5 meg to perform and get 7, 8, 9 megabits of capacity out of it too as well. So as we think about best practices for leveraging broadband in the enterprise scenario, you buy as much capacity as the site can afford, magnify the amount of capacity that's available to you, and then inside that available capacity, we want to intelligently prioritize the traffic that's going through. In addition to magnification, one of the things that we want to think about is that as the nature of traffic continues to evolve, there's increasingly an increasing norm of all applications becoming more and more encrypted. And this makes prioritization challenging in a large extent. If you can't see what's if you can't inspect the packets, how can you actually prioritize them? Some of the other best practices that we think about is, well, if you can't see what's inside the packet, the next best thing is to see what the traffic looks like. We can tell the nature of traffic by its shape. That top line stream, consistent small amount of data on a continuous basis, most likely a voice data stream. And because we know that that's likely a voice data stream or a video data stream, we know that that needs to be prioritized. That needs to get its first opportunity at the traffic of whatever is available. Otherwise, if I let it take a back seat, I might get the pops or hiss. I might get the poor employee or customer experience. The small little blocks that are passing back and forth, those are most likely credit card transactions, or maybe some kind of inventory application, or just some kind of small little data transaction that a customer may be doing at a kiosk or at an ATM. Because it's a small transaction and because it doesn't impact the network, I know that, and because it's most likely a point-of-sale transaction, I know that too probably needs higher priority too as well. The bigger blocks of data, that's probably my guest Wi-Fi, or it's some software upload or download. I can deprioritize that traffic, even though I can't see what's in it. I know that if the streaming and the smaller transactions are the more important to my business, it's more important to my employees' experience, it's more important to my customers' experience. And then the bigger bulk loads, far more flexible in terms of being able to take a back seat to these other higher priority applications. And so if we can be more intelligent about how we characterize traffic, even the stuff that we can't see, we can dramatically improve its performance over even a broadband type of network. And so some of the things that we're looking at and doing here is we want to be, what's exciting about this is that it opens up the opportunity to dramatically simplify the classification of traffic. One of the big challenges that we have, many of our customers will have, is as they look at their prioritization schemes, there's just simply too many rules to manage. They can literally have hundreds of ACLs, access control policies, that they need to manage on a continuous basis. And if they get any of them wrong, then there's a direct and immediate impact to the performance of the store or to the restaurants. What's kind of exciting about this is the ability to take a platform and just introduce it into the network and just have it intelligently understand the difference between my voice traffic, my small transactions versus my bulk data loads. And on a heuristic type basis, on the nature of the traffic itself, we make our priority calls. And so what we're seeing in some of our testing is some actually meaningful improvements in terms of response times now. So going back to that clienteling example, that little video that opened the presentation with, we want to dramatically improve the experience of the customer or the clienteling, whether it be a clienteling app that a salesperson is working directly with a customer, or an ordering kiosk in a restaurant, or even a universal banker type tablet type solution that a teller might be working with a customer with. And regardless of whether the application is encrypted or not, by just looking at the nature of the application, we can be far smarter and far more intelligent about how we characterize it and how we manage it, and dramatically improving both the employee and the customer's experience with the applications. So we're seeing some fairly exciting results with these type of techniques in the marketplace. We have a number of customers where they have fairly large deployments, maybe 1,000 sites nationwide, and they're still having challenges in some cases getting enough capacity. In many cases, some locations will only get or be limited to like a 1.5 or a 3 meg broadband. But with these best practices, again, magnifying whatever available capacity is affordable and available at a location, and then being able to intelligently prioritize them, particularly the point-of-sale transactions over the other third-party or cloud-based type applications, we're able to get consistent results, consistent point-of-sale transactions, and making the most of the opportunity of what's available with the resources that we have in front of us. So the short of this is that we look at this as part of a kind of a broader solution template. When we think about the wave of all the new applications that are hitting these markets, whether it be restaurant, retail, or banking and finance, there's going to be a meaningful need to rethink about how we provide the underlying infrastructure to support all of these types of engagements, all the new applications. And the old world of, well, T1 is good, it's reliable, but it's expensive and it's small. And broadband is cheaper, but it's got more capacity, but it's a best efforts type solutions. There's a third option now, where we can actually take the broadband type solutions, and then with the innovative technologies that are available to us today, we can extract out of those best efforts type circuits an enterprise grade experience. And then this will feed into the security infrastructure, the availability, capacity, and all the other things that will be part of the powerful network that supports this new wave of engagement. So that's what I have for today. If there are any questions, feel free to chat them in. Otherwise, we're going to have this recording made available to us, made available online, and available for you to review at your leisure.
All right, well, we don't see any chat questions coming in right now. We will be sending this out tomorrow to all of the attendees as well as individuals who registered. So please look for that email coming out, and then feel free to reach out to us if you have any other questions after you've reviewed it again. Thanks again for joining.